What's going on, math people? We are back and we're talking about log differentiation. If you see this information down below, that is all information from college algebra. So this is stuff that we need to recall in order to make sure we're going to bang out this section on log differentiation. All right, if you look at the rules listed, you'll see log, and below where I've written in blue ink, you'll see the natural log. The properties are the same. That I'm not saying that log and natural log are the same. I'm saying that the properties are the same. Okay, they have the same property approach. All right, so natural log has a base of e. Log, it gives you a base given. It depends on whatever the base is chosen to be. All right, so let's just jump straight into this because you'll need to be able to utilize these properties to knock out some of these this log differentiation. All right, now that we've recalled the algebra, let's talk calculus. All right, the derivative. All right, so let's say we have dy dx of the natural log of u equals, and I didn't mean to write dy dx. Let me clean that up. Let me say that better. Like, let's say if y equals the natural log of u, and u is a differentiable function of x, then dy dx is equal to 1 over the derivative of 1 over u times the derivative of u with respect to x. Because we have to throw in that chain rule. And that's anytime you take the derivative of natural log. It'll be 1 over whatever the expression on the inside is. That's every time. All right? So let's toss in a real smooth example. First, we have y equals 6 natural log of 10x. Problem says find dy dx. All right, so going ahead and getting real mathy with it, we have dy dx equal, we have 6 times the derivative of the natural log portion. That's 1 over whatever is inside that parenthesis. Then the chain rule, which is times the derivative of what's inside the parenthesis. It's just 10. Final answer, 6 over x. I know, too easy. Way too easy. Slow the video down. Try it again for you. All right, let's toss in one of these bad boys where we're going to have to apply some of these properties that we have up here talking about. We got to recall all these properties. Say we have y equals natural log of t to the 10th. Now you can do this the long way or you could do it the short way. The short way is applying the property, and you have 10 natural log of t. All we did was apply the property. If we're going to find dy dt, after we apply the property, we'll have 10 times the derivative of the natural log piece, and that gives us 10 over t. That's the short way using after the property was applied. The long way Let's say you did not apply the property and you went straight into t over 10, and so that was taking the derivative of the natural log piece times the derivative of t over 10. That will give us with 10t over 9, 10t to the 9th over t to the 10th, which simplifies to 10 over t. Hey, whichever one floats your boat, but I hope you can see how knowing these properties will start to save you some time, and as we progress, you're going to see that it's going to save you a tremendous amount of time. All right, so let's get a problem that's a bit more challenging, where we really got to incorporate some of these log properties like out the wazoo. All right, going into pure log differentiation now. Let's say we have y equals, I don't like that. I don't like that look. So with this example, we have y equals t times t plus 5 times t plus 9. All right, so rewrite using log properties. This is where the game gets real, okay? So I'm going to take the natural log of each side so I can start using my log properties. So I took the natural log of y equals the natural log of everything that was on the other side. All right. Now, right now, log properties, that leaves me with natural log of y equals natural log of t. This is a product, and a product says I can separate all of those by addition. Notice the log property that I use. I'm going to just scroll up real quick so you can catch that log property. The log property that I use is that product rule. You see the product rule there in blue at the top. All right, if I have a product of things inside my log, I can separate each of those each of those factors by addition. I just did that. Now that I've done that, go straight into the calculus. All right, going into calculus now. We're going to take derivative, and we're going to take these derivatives in blue. All right, so derivative of everything, and we're taking derivative with respect to t because we're trying to find dy dt. So this starts to pull back in implicit differentiation, the whole 9. So we have 1 over y times dy dt. Watch this move right here. This is why I like these log properties. You're like, what's going on? Check it. I'm going to take the derivative of the natural log of t. T goes in the bottom. Derivative of t, natural log of t is plus 5. All of that stuff goes in the denominator. Now, going back, watch this move. What's the derivative of t? 1. Derivative of t plus 5, 1. Plus the derivative of t plus 9, 1. We're about to be finished with this problem. This problem would have been a mess if we wasn't using log properties. Do you see how many times we would have to use the product rule or multiply all that stuff out? All right, so the next thing we do, we find in dy dt, we multiply each side by that y, and everything else just comes right into that parenthesis. I I know what you're asking yourself. What is y? Y is the original function that you were given. So instead of writing y in your solution, you have t times t plus 5 times t plus 9. That is y. We just put in y times 1 over t plus 1 over t plus 5 plus 1 over t plus 9. Boom. We just calculated dy dt without having to do all those variations of the product rule. All right, we're going to do one more example of log differentiation, and we're going to get out your hair. We have y equals x square root x squared plus 6 over x plus 8 raised to the 7/3 power. All right. Okay. First thing we're going to do is rewrite all of this madness. And we have y equals x times x squared plus 6 raised to the 1/2 power over x plus 8 raised to the 7/3 power. Add in logs. Add in the natural log rules. So we natural log of y equals the natural log of all of that other stuff over there. All right, time to apply log properties. Applying log properties, we have natural log of y equals, for the numerator we have a product, so that's natural log of x plus natural log of x squared plus 6 times 1/2. Then we have that division minus natural log x plus 8 7/3. All right. Apply the log property one more time to bring those powers down as factors in the front. Natural log of x plus 1/2 natural log of x squared plus 6 minus 7/3 natural log x plus 8. All right, catch this with me. Time to do the calculus. Calculus is the easy part. Take this derivative, both sides. Apply implicit differentiation. Equals. Y'all know what we're about to do. Plus, put that 1/2 right there in the front. It was there. It stays. I'm going to put that minus 7/3 right there in the front. It stays. Goes in the denominator. Everything that's inside of the parenthesis. All right. Next thing. Derivative of x for the first term is 1. Derivative of x squared plus 6 is 2x. Derivative of x plus 8 is 1. Simplifying. After simplification, we have 1 over x plus 2x over 2 times x squared plus 6. What happened to that 1? 1 times 2x gives us 2x. Minus 7 over 3 times x plus 8. Notice I tossed everything in that parenthesis in those denominators so that you can see that the multiplication goes throughout. Final step, moving that y to the other side to get dy dx alone. Dy dx is equal to y times all of this other stuff. Minus 7 over 3 times x plus 8. And to put your final answer in, you go ahead back to the beginning of your problem. It says, what is y? You take that y and you plug it into that equation. Alright? I just had a thought. I was going to let y'all go, but there's a problem. Problem type that can really wreck your world if you haven't practiced any. So I'm going to get, for real this time, I'm going to give you one last problem. Let's say that you have a problem that puts a variable in the exponent location. If you have a problem that puts a variable in the exponent location, rewrite by taking natural log with log properties. Alright, so we have natural log of y equals natural log of x to the 9x plus 8. Apply log properties, bring that power down as a factor. Natural log of y equals 9x plus 8 times natural log of x. Alright, so finally, start taking the calculus role. You have 1 over y dy dx equals, I'm going to apply the product rule, the derivative of the first times the second plus derivative of the second times the first. Multiply each side by that y and you're out of here. Dy dx is equal to y times 9 natural log of x plus 9x plus 8 over x. What is y? Y is what you started with in the beginning, so when you plug that in, final answer, x to the 9x plus 8 times 9 natural log of x plus 9x plus 8 all over x. Alright, that's my time, team. Thank y'all for chiming in. I hope this video helps you out. As always,